All right, class. So this is 4-6 and it's matrix equations. Basically, we're going to use the idea of an inverse to solve a system of equations with matrices. So we know the long method where we could do those row operations using a matrix. This is a different way. It's using that inverse. So the first thing I want us to do is look at this idea right here. Oops, let me put a highlighter right here. That is not a highlighter. This right here. So the idea is if I want to find what numbers solve an equation, that's what it's asking for here. I can take the inverse and times it by the coefficient matrix. So inverse kind of times your coefficient matrix. So that is the idea of this section here. So these first couple, it says, let's write it in this form right here. See, AX equals B. Let's do that. But I also want to maybe take problem 2 and show you how to get an inverse on the calculator, or maybe we'll wait. Well, I am going to show you a quicker way to get that inverse. So this function here for problem 1, it wants you to come up with what is A. So A is going to be the coefficients from your matrix. So it'd go 8, 3, 3, 5. That is A. Okay. And then X is going to be X1, X2. Sometimes that's XY. But basically that X part is going to be X1, X2. And they use X1, X2 a lot in the calculators. They use it a lot in this textbook, but it could be XY, okay? And then it equals this number over here, the 14 and the 13. So this is the idea of AX equals B. And I probably shouldn't have the A on there, but so we should write it like that. So that's all it's asking you to write here. So you will be doing that. You will be writing a coefficient matrix. That is this right here, right? Oops, I'm on eraser. That is this right here is our coefficient matrix. And you could see they talk about it right here. Okay, and then these would be our unique solutions. So basically, if I can take the inverse, I have a unique solution because I would get an error and have no solution or many solutions if there is not an inverse. So we could easily write the coefficient matrix on this one, 4, 2, 5, 3, and then we end that, and then we say our X1, X2, and that has to equal 8, 4. All right, so let's skip down to finding the answer using these inverses. So you can notice this first one here, 5, they already took the coefficients. They already wrote this in this format. So we know what we can do is find the inverse of this one right here. And we can then times that inverse by the 14 over 13, and we will get our two solutions. So our goal will be inverse times B, okay? And B, this is B, okay? And that is going to equal, what do we call the X1 over X2? I think we just called it X, right? That's going to equal our X's, okay? And these are our X's. And we need the inverse here. So this is just A, but we need the inverse. So watch this. I'm going to put my iPad on camera mode and show you on the graphing calculator. So bear with me for just a sec here. Look at all my stuff. Don't mind my clean office I have going on here. Okay, so sorry, I forgot to move this up here so I can get my iPad high enough to see really well. Go. Okay, so we have on the graphing calculator a section over here for matrix. Okay, and the way that this works is we hit secondhand matrix and we'll get this part to come up. Man, I almost wish that was even higher. Maybe if I do that. So secondhand matrix, and basically you can arrow over to math. These are the different things you can find. Look at the identity on there. We like it. And the edit section. Okay, so names, math, edit. So we start with editing. I usually keep a 2x2 and a 3x3 in here. We have a 2x2. So I'm going to go in and put in our values from our problem, which were 8, enter, 3, enter, 3, enter, and 5, enter. So now I've created a 2x2. If yours didn't have a 2x2, you can change it here. And again, I went into secondhand matrix and I'm in edit and I edited matrix C. So you can edit whatever matrix you want, like that. Okay, now that I edited it, I'm going to get out, quit, go back to this mode here, and I'm going to call back. So I'm going to go matrix and call C. So the name, I hit enter, and it'll just say C, matrix C. And I could then hit this key right here and get the inverse of that matrix. So it's definitely decimals. We arrow over, we can get all 4 numbers. So pretty cool. I'm going to show that again. So I'm going to go secondhand matrix, go over to edit, and I'm in the 2x2. I put in my numbers and then I go out. So secondhand quit, and I'm going to clear off what's there. Then I'm going to go back to matrix, call up whatever matrix I edited, and I'm going to hit the inverse button and enter. Okay, let's say your calculator is super old and doesn't have the inverse key. Another way you can do it is we want to go to edit. We'll do it on this second one here is fine. And I'm going to change this to a 2x4. Okay, and then I'm going to put in the 8, the 3, and then I'm going to do the 1 and the 0 for, and the 1 down here for the identity. I'm going to go back over, and this was a 3, and this was a 5. Okay, and then I have the identity over here. So then I've put everything in the edit for my matrix. So then I'm going to hit secondhand matrix, and I'm going to go to math, and I'm going to go to, I thought it was, yeah, reduced row echelon form. And I'm going to say matrix B, I think is how we did it. Uh-oh. Reduced row echelon form. Why is that 2? I don't know. Okay, secondhand quit. Clear. There we go. Let me try this again. Matrix math. Reduced row echelon of matrix C and enter. Yeah, that's totally of C. Oops. Hold on. I secondhand enter. It was not C, it was B. Goodness gracious. Secondhand matrix math, reduced row echelon form, yet again, of matrix B. Excuse me. And enter. There we go. So there's our 4 numbers over here as well. So remember that method of all the row operations I made you do in the last section? You can do those row operations. So reduced row echelon form is the form that will give it to you. So RREF. So write that down. So if your inverse doesn't work, which it doesn't work on my older one, then try that method. Okay, so now we're going to bounce back to doing our lesson. Let me open my Notability here. And now we kind of have a shortcut way. So this is why we're learning the inverse, is because we can use it, we can get it really quick on a calculator. Well, I have it right here. It definitely was decimals. And I wonder if I can hit secondhand math fraction. Oh yeah. I hit math fraction and it put fractions for me. Okay, even cooler. So I went, whenever you have the decimal, you can click, let me get out of this, math right here, right? Math. And the top button is fraction. It will take your last answer and make it a fraction. Bam, that's so much easier to read. Okay, so now we're going to go back over here and we're going to say, well, the inverse was 5/31. My goodness, it was ugly. -3/31. And we just saw all the decimals. And -3/31 and 8/31. Ew. And we want to times that by b. I wonder why they gave such ugly numbers on the first one. Well, probably because in the real world, it is ugly numbers. And this will get us out x1, x2. So what we do is then we use our matrix multiplication. I wonder if we can do that in here too. So I'm going to go to matrix. It was our 2x2. And then I'll go to a 2x1. I'm going to put in the edit 2x1, and I'm going to put in the 14 and the 13. And okay, enter. And then I am going to go back. So when I did that, I just went into the matrix section, right? And I put a matrix in that's a 2x1. So I still have to go to matrix and I have to go over to edit on the end in order to get that to come up. So I'm going to call out now, I'm in the basic function. I'm going to call out C, which is, oh wait, I want the matrix inverse. Well, okay. So I'm going to call out, it was my 2x2. I'm going to just tell it the inverse. And then I'm going to times by the 2x1. Oh, yeah. It did it. It might be backward for you. It did it. So what's the moral of the story? Put your matrices in your edit function and you can times them. But if I didn't want to use that function, what I could do, so I know that the answer is going to be 1/2, okay? X1 is 1, X2 is 2. But what I could do is I could use the method where you times this way, right? And times down, add that together to get this solution here. Okay, so let's do that. And we can do that on our calculator. So it'd be 5 divided by 31 times 14. And add that to -3/31 times 13. Ooh, that's ugly. But that gets me that same value right here of the 1. Okay, so I did. So I did this again times this, and we did it individually. This one times this one, add this one times this one, and got just that number here. Okay, so then we could do the same thing again. We times this row and this one, and it will add to this number. And it'll give us a 2. And so we could easily do the fractions in our calculator. No problem. Use the division. You don't have to do anything else. So here's our solution right here. Beep, beep, beep. Right. Problem 6. Let's do this again. So what do we want to start with? We want to start with getting the inverse of A, right? So A's inverse is going to be what? Well, let's see. So I'm going to clear that off. Okay, I'm going to go to matrix. I'm going to go to a 2x2 oops, I don't know what I just hit. Oops, I hit graph instead of arrow over. Edit the 2x2. I'm going to edit my 2x2 to be 4, 2, 5, 3. And then I am going to go back to matrix and edit the 2 by 1 to be the 2 by 1. I want the 2 by 1 to go 8, 4. I just find this a little bit tedious in the calculator, but that's okay. So then I am going to call back. So I'm back to a blank screen because that's the part that messes people up. And I call back matrix A. No, it wasn't in matrix A, sorry. Call back matrix C for mine. And I'm going to tell it the inverse. So I put it in like inverse, right? Here, let me do something real quick. Video settings. Don't mirror my image. So then you can see it better. Okay, so then from there, I've got that, right? The inverse. And I am going to times, just push times by push into the matrix and call in the 2 by 1. That one's in D. So I've just put it in like that and hit enter, and it'll give me the 2 solutions. Okay, so times that by 8 by 4, 8 over 4. And I don't even know what the inverse is, but I know the solution is 8 over negative 12. I didn't even get the full inverse. I can't real quick though. It was 1.5, negative 1, negative 2.5, and 2. Okay, so I find this section kind of fun, I'm not gonna lie, because I can use a matrix with technology very easily. And so, and I know you can use matrix in Excel. I've done it once, but it's kind of hard. But I think there's a Desmos matrix calculator. It's in beta. There is. So it doesn't have an app, so it would only be usable on your computer, but there is a Desmos matrix calculator. So if you don't have a calculator, you could try that one if you don't have a graphing. Okay, so we just went, this goes through like problem after problem doing the same thing. And then problem 9 is awesome. It shows you, why would I want to do this? So problem 9 is like, okay, take this part right here, right? Take this part, and you can easily then just change what you times it by over and over. So you make an inverse and you can times it by all these other situations. So can you take a business situation and times it by all sorts of options? Yeah. Or I have 3 businesses, all of, McDonald's or something. And I want to, this is from business 1, business 2, business 3, and you can look at it really easily. So there are ways you can use a matrix to solve things faster. Same idea for 10. They always do a couple. Okay, definitely want to do this one. I thought there was, look real quick. There's 12. I think those are the only 2. Okay. So construct a mathematical model for the following problem. Use matrix inverse method to solve this. So you're going to have problems like this in my class, and you're going to have like 3 methods, I think, to solve them. And this, you have to read the directions for the exam too, because you'll have to use the specific method it asks you. Okay, so this is our dog food. And it says, a dog food manufacturer makes 2 types of dog food, Sparky's Special and Fido's Favorite. Each type of dog food uses 2 additives, additive 1 and additive 2. Okay. And then it says how much additive each type has, and then how many bags of each type of dog food could be made to use exactly the amount of additives available on any given day. Okay. So let's look at what they used in. I'm going to use an X for additive 1. And I'm going to use well, let's do that x1, x2 thing that they always do, additive 2. Could have been, could have been either way. Then we're going to do each situation. What do they have? A1. Sorry, I was looking at theirs. I don't know if I love theirs. Where's mine? I had this little chart thing. See, that's what I get. I don't know. Okay, so we're just going to think of, all right, so Sparky Special has 5 units of additive 1 and 3 units of additive 2. So Sparky Special, how did we do that? I think we went Sparky Special. And then I did it. I wanted to show you the chart, Fido's favorite. So here's Fido, and here's additive 1, and here's additive 2, and we'll do a little chart here. And Sparky's favorite needs 5 of additive 1, and we call those X1, which we'll deal with in a second, and 3, and then Fido's favorite needs 2, right? So 2, and 4. Okay, and this will get out our amount of additives over here when we get this out. So this is kind of the chart that I could think of. I was trying to remember exactly how they did it in the example to follow, but they may do it a little bit different. So basically you have each type right here, right on the tops, and then the additives down the side. And then these could form equations for you. We're going to call, well, Sparky X1, X2. Maybe I should, oh well. Additive 1. Okay, we're going to call this 5 times, they do X, it doesn't really matter. I mean, S plus 2 times, let's see, I can't call these X1. Sorry, guys. I'm like, oh, I was trying to do something different and make it like a chart. And then I'm like, let's just call these Sparky. Oh, it was still an eraser. And that was a 5. Let's call these Sparkies and call these Fidos. Okay. So 5 Sparkies plus 2 Fidos is going to equal additive 1. That's how we're going to do it. Okay. Then 3 Sparkies plus 4 Fidos equals additive 2. So once we've set this up, what we're going to do is, and setting it up will get you, then we're going to write our coefficient matrix, right? 5, 2, 3, 4. And this is our, basically it would be the A, right? Our coefficient matrix. And then we can find the inverse of this. Okay, so we'll plug that into our calculator and we'll get the inverse. Our inverse would be 2/7. And this one, you might be able to just do our determinant method, right? 5 times 4, 3 times 2 will give us, subtract them, 14, 1/14, switch, change the signs. You could still do that inverse method with that 2 by 2 by hand because it's not that bad. With a 3 by 3, no thanks. Okay, and then this would be minus 3/14 and then a 5/14 over here. Okay, so the inverse is this, and then it gives us different amounts. So for the first one, I'm going to times this by, if you go up, the 160 and the 180. 160, 180. Okay, so then you can plug that into your calculator, but you take 2/7 times this plus this one times this, and that's going to get you this first answer of 20. It actually works out really pretty. And the next one's 30. So here's why I'd want to set up the situation is now when I go to do B, I already have the inverse. So all I have to do is change this part right here for each piece. So for B, we would just change, we use A, whatever, times the 141 over 107. So we can look at this other situation and still use our inverse. So for B, they get 25 and 8. Okay, additive 1, additive 2. So you could say this like, this means you should produce 25 bags of Sparky's Special and 8 bags of Fido's Favorite, because you're finding Sparky's and Fido's. So let's write that out just so you have it in your notes. This is 25 Sparky's bags, right? And this represents 8 Fido's. And up here, this represented Sparky's and Fido's. And so if we have this much additive, the 160, 180, I can make 20 bags and 30 bags. If I have this much additive, right, then I can make this much of Sparky and Fido bags. Okay, word problems are going to take us some time. Let's try Farmer Phil's. Okay, Mr. Phil. Farmer Phil. So he needs to treat his field with potash. I don't know how that's exactly said, potash, and nitrogen. He can use Grow Right brand and Great Green brand. Grow Right has 3 pounds of the potash, 5 pounds of the nitrogen per bag. Great Green has 1 pound and so forth. Okay, so when we go to set this up, we could think of it as, what is the first one? Grow Right. Grow Right. And the second one was Great Green. I can't really use, I was thinking use G, and I was like, they're both G. Okay, so then we could think of our potash. What was the first one? Potash, right? 3 pounds, yeah. All of you farmers are probably like, it's potash or potash or I'm totally saying it wrong. And here's our nitrogen. And then I think, okay, for Grow Right, I need 3 and 5 per bag. And this one, I need 1 and 2 per bag. And I'm going to get out the amount of this one and the amount of this one. P and N stands for the 2 types, potash and nitrogen. So let's set up our formulas. So this will be, let's call this G1 and G2 because they're ridiculous and they're both G's. So we would say G1 is 3 times G1 plus 1 times G2 is going to equal the amount of P's, and a potash 5 times G1 plus 2 times G2 is going to be my nitrogen. Okay, so then we set up our matrix. So it will go 3, 5, 1, 2, and then we have to find our matrix, our inverse matrices of that. And I'm going to cheat. The inverse is 2. It's not really cheating. I just already put it in my calculator, -5, 3. But you could tell I probably put it into my calculator last year because I was like, oh, how do I do it again? No, it's not too bad. Okay, and then we're going to times this by each situation. So for part A, we're going to use the 1320. And this is for part A, and the 2,240. So we times those 2 together, and that's going to get us a lot. So 400 bags and 120. These are our answer here. So it equals this. And that is equivalent to What did we have on the top, right? What was our top one? Was G1, right? And G2. G1, then G2. X, Y, G1, G2. So 400 bags of G1, which was Grow Right. And then we have 120 bags of Great Green. All right, I'm not going to do B and C. It's the same thing. All you do is switch your numbers here. So what we like about this method, when would we actually use this method? When we have different situations like this one, where I'm given other ones with different pounds, and we want to see how many bags we can make. So if we have a bunch of situations, we can do the inverse and times, get the answer, times, get the answer. And so we can just use that same inverse over and over and over. So in business, it can be really handy, and you can make technology do it for you and get your answers if you understand how to set up a matrix. So that's why you're in this class. All right, that's about all for this section. I thought there was one more. If there's another problem, I thought there was one that was kind of tricky that some people struggled with. Maybe I'll add this to the bottom here. I have like problems that people send me often. That one doesn't. What if we did? If you feel like you get it, you could probably stop my video, but what if we do this with a 3x3? And one other idea that, okay, one day, okay, let me just point out a couple more things, I guess. If it's not square, can't do it, right? Because inverse method isn't going to work. So you do have a couple problems that were like a 2x3, or they had XYZ with only 2 equations, can't do it. So remember that. So the coefficient matrix has to be square. The coefficient matrix is singular, no solutions, many solutions. So basically, if you have a row of zeros, you know, right, you can't get the inverse. So that's not going to work. All right. One other thing is they try to make you solve some things with the matrix formula. So they may say something like, extra problem number 1, I guess. They may say something like X times A equals B. Can that imply that X equals the inverse times B? Is this correct? They want you to be able to think through that your inverse be they want you, I don't know if you would think this on your own, but they want you to think through that B times the inverse is not the same as the inverse times B. I don't love the way they write this part out, but you need to know this, right? I have to be careful the way I times. I cannot times backward like this one kind of. You can't, because it actually doesn't, it won't work. So this one's just trying to talk about that formula and making sure it works right. What other one? Because these are called the basic formulas. These are the basic properties of a matrix. X. No division allowed. No division allowed on any matrix. Basically, just stick to the one we did. That's the only one I really care about. You might see a little chart come up in the note or in the homework, right in the example, that talks about all the different things for matrices. If you take linear algebra, you'll go through more. For us, our biggest one is from that very top of our page, whoop, all the way up. This idea right here. If I have this, I'm going to use this. And this is basically timesing both sides by the inverse. And that does get me this. Okay. But we got to make sure we're doing inverse times B, not the other way around. Okay. And then one more 3x3 problem. Let's do that real fast. So then the 3x3 would look like, so this is just problem 2. If I had a coefficient matrix, so I can start with equation if I need to, and then I would put the numbers in for my coefficient matrix, and maybe it looks like this. Oh, right. And then on this one, this is going to be our A, and our B was given as 1, 1, 1, 1. Okay. So that is how they set it up originally was, here's the equations and they all equal 1. Okay. And then we're going to set it up into our matrix like this. So we can use our calculator for a 3x3 also. So you just get out the calculator. You're going to go into the matrix. I have a 3x3, so I'm going to edit my 3x3 to have the numbers that I see. So 1, -1, 1. You'll notice it goes across 0, 2, -1 when you type them in, 2, 3, 0. So I typed them all into the edit. Then I'm going to go secondhand matrix to go back, or just out, quit, secondhand quit, clear off everything. And then I'm going to hit the matrix again, and that is in A for me. So I hit enter, and then I say inverse, enter. And there's my inverse. Okay, so I'll write this down. The inverse is going to be 3, 3, -1, -2, -2, 1, -4, -5, 2. And we're going to times this by the 1, 1, 1, 1. So if I would have wrote the 1, 1, 1 on the other side, and this is a 3x1, and this is a 3x3, think about it, if I have a 3x1 and then a 3x3, you can't even multiply those. So it can't even be done if you try to do it the wrong way. Okay, so we could do this as our 3 times 1, which is 3, 3 times 1, which is 3, -1 times 1 is -1. Add those all together. I get 6 minus 1 is 5. So you could do this without a calculator. I get 5. Do it again. -2 times 1, -2 times 1, 1 times 1, -4 plus 1 is -3. And then -4 times 1, -5 times 1, right? Timesing them by the ones over here, is going to give me -9 plus 2, which is going to go back to -7. And that's our answer. So we could go all the way back and say x1 equals 5, x2 equals -3, x3 equals -7. We needed to. So you can still easily do it with a 3x3, just as quick as a 2x2 with the calculators. All right. Good luck. Let me know if you need help.